We must be cautious when we do age adjustment if our intent is to compare two different groups. So for example, here is a sex breakdown of mortality over the last 60 years in the US. And we see that the top line is males and the bottom one, so this is males and this is females. And we see, it looks from this, this is if we just count the number of deaths, it looks like, sure, there's more men dying all the time, but now the gap has been closed up, and there's, in fact, it looks like it's slightly overtaking. Women are slightly overtaking. But once again, this is just counting the number of deaths, and we saw that that's not a good thing to do because the population size could be changing. And in fact it has. But what's interesting here is, does it change proportionately differently for males and females? So indeed, if we now correct by population size, now be careful, you look at the population of males and you look at the population of females and you do your division appropriately, there it is. So now the crossover has disappeared, but still we see it's closing up, the distance is closing up. But is this fair? Because the population's profiles might be changing with time. The same question we raised a few minutes ago. So if we look at the age-specific, and this time also sex-specific mortality rates over that same time period, we see that a similar picture, but we see that by the end, the male rates are higher than the female rates. And they have been all along. When you compare them, so this is the 85 and over, this is the 85 and over, compare them across, and the under one and everything. The male mortality rate is always higher than the female mortality rate. So it's going down, sure, but just as the population was getting older when the rates were going down for everybody, so too now we see that since they're going down differently and they're less for females, females should be getting older more so than males. And in fact, if we look at now this is called an age pyramid. It's two histograms lying side by side. If we look at this, then we see that in 1940, this middle line here, that's supposed to be a straight line, which on the left is males, on the right of that is females. So you've got to look at it this way to look at the histogram for males, and you've got to look at it this way to look at the histogram for females. But you see that line is pretty much in the center as it's coming down. Whereas because of these differential mortality rates, by the time we get to the year 2000, look what's happened to that center line. There it is, that center line. And we see many more females, especially in the old age groups, many more females. That's the female and that's the male. That's the female and that's the male. So there is this sort of 50-50 has now changed dramatically, and there's many more, proportionately, there's many more females than males. So if we're going to do an age adjustment, we've got to do a different age adjustment for males as we do for females. And in fact, when we do that, the solid lines result. So here they are, the solid lines for males, the solid lines for females, age adjusted. You see this grouping together that we saw without age adjustment has now disappeared, and the age adjustment shows that the gap is very much still there. In fact, if we take the ratio of the male to female rate, yes, it's coming down since the late 70s. That's when it reached its peak of 1.7. It's coming down now to 1.4, but it's still very much there. So be careful and just use the appropriate age adjustment when making comparisons.